Hey everyone, welcome back to my workbench. My one webcam's being stupid, so kind of a throwback. I don't feel like showing my face today anyway. It means I gotta clean up the rest of the room, and it's kind of messy right now. So what I'm working on is the Intellivision II controller again. So what that means is I'm going through and creating the, first I'm gonna figure out the keypad here. Actually, I'll move this up a little bit. So the ultimate design, I think, is going to require it's going to be a bit of transistors. I think 7. Before I was wiring up the 3 columns, I realized I need to wire up 3 rows instead on the keypad. So for now, I'm putting in a bunch of transistors. I probably need a bunch of jumpers too to fully wire this up. So this is column 1, column 2, column 3, and we need 4. Talking to myself here, I need 4 for the. Actually, I'll make these 4 for the. These 4 will be for the diagonals, because those will actually come from, this is an AND chip, and the output of the AND chip is going to go to the these to pull down the directions. This is actually going to be pretty straightforward. What I need to figure out is the transistors is a collector base emitter. How it works is see if I can more education here. I know you don't want to learn, but I'm going to teach you anyway. Okay, so how it works is it's completely white and blowing out the camera, and you can't see a darn thing. That's how it works. And where the heck is my little sketch pad? Oh, I need to clean my office. Do this with a marker so you can see it better. Alright, so collector, base, emitter. So the whole theory behind what I'm working on here is, here we go. Here's your collector, here's your base, your emitter. So this goes to ground. This is actually going to come off of, well, let me draw that. So you're going to have a 1K here. No, it's going to go this side of it. Not connection there. That goes to ground. So when you press a button, you're going to get a drop across this 1K resistor, which is going to energize. You're going to get there's 5 volts here. You're going to drop, I don't know what the heck it's going to be, but you'll get a voltage at this point here, and that'll turn on this leg, the base, and then this operates as a switch. So if there's no current flowing into the base, then say this is column 1, you're going to have column 2 and column 3. So what happens is when you press one of the rows, it's going to get shorted to ground. Well, not shorted. It's going to go through 1K resistor to the ground. That's going to allow current to flow through the base, through a resistor here. It's probably going to be like a 63K-ish resistor here. You need a tiny amount of current. Tiny amount of current flows through here, and then I'll probably put a 1K here just to have it all balanced. So what happens is when you press this button on the keypad, one side's going to get, the row is going to get pulled down. Say this is row 1. You're pressing the button to 1. So it's row 1, column 1. So row 1 will already be pulled down to ground, more or less. And the Intellivision will see, okay, row 1 is pulled down. And that's this guy here. Row 1. You have row 1, row 2, row 3, row 4. Right? So pin 4 here is row 1. Row 2, is row 3. So row 1 is on pin 4. This is on 3. Row 3 is on pin 2, and then finally row 4 is on row 1. So what that means is when you press the K1, keyboard 1, this will already be pulled down. This is inverted logic, so this is going to be pulled down the ground. And then this is column 1. So column 1 is on 6, column 2 is on 7, and then column 3 is on 8. So this column 1 will be, just like I showed you here, this is column 1 right here. So as I press this down, you'll have voltage drop. It's going to see the logic's going to be, okay, row 1's pulled down the ground. Then this transistor here will switch and pull column 1 down. So it'll know I press key 1, row 1, column 1. And that'll say button 1's pressed. So what that means is I need a crap ton of transistors to do that. I need 3 transistors, 1 for each column on the keypad, and then I'll need 4, 1 for each diagonal. I think I might not need all 3. I have to work out the logic on that one, but what I'm thinking is, I'm just placing transistors right now. I'm thinking is I'll have to see how that logic works. I'll show you how it's kind of interesting how it's actually a 16-way controller, which I have no idea why, but I'm not going to split hairs on that one. I don't know why you need a 16-way, because every game I've played is like, my God, I'd kill for a 4-way or 8-way joystick. So your cardinal directions are D1. You can see it here. Your cardinal directions, you get your D1. See how it says single output there. And then you have your D5, which is this guy here. Then you have your single one D9, and then finally your direction 13. And if we actually look at the logic here, oh, thank goodness for people doing research. Okay, like I said, here's the direction 1, direction 5, direction 9, direction 13. So I'm going to just be emulating 1, 3, 5, 7, 9, 11, 13, 15. So I'm going to make an 8-way. But you notice every time you're in the diagonal, this is D3, which is upright. That 9 gets pulled down. So I need to have logic so that I'm pulling down, when I'm pushing that, go in that direction, it's fine, because I'll just have, this is going to go to up, right, down, and then finally left, which is fine. So we'll get 4 ways for free, no big deal. However, you'll notice in the diagonals, you have 2, and it has pin 9 come down as well. So this is where my AND gate's going to come in place. So this guy and this guy will be pulled down the ground, ANDed. Where is it NANDed? Oh, I can't remember what the heck the logic is. No, it's going to be ANDed because I'm going to be talking to myself here. I'm going to be dropping through 1K resistor. It'll go high on AND this, and then it'll drive the output of the AND gate high. And then the output of the AND gate will go into the base of the transistor, just like the keypad, and that'll cause the 9 to go down the ground. So I might be able to get away with, I need just 1 transistor, because it's and that and that. Oh yeah, I can do that. Maybe not. No, I can. I can do 9. I can do just one transistor there. Because it'll just feed into the AND gates. I'll have all 4 AND gates together. Yeah, I'll experiment with that. Okay. Again, talking to myself here. So, now, where were we? Alright, now we got to wire up the rows together. So, alright, row 1 is on pin 4. 1, 2, 3, 4 is yellow. Yellow goes over, what, male to male. Yellow goes over here. That is your row. That goes directly into, back to my paperwork, that goes into row 1, which is there. Row 1 is, there's a dead pin in that one, so that's row 1. Can't get you out. Get this out of the way, I don't need any more. Anywho. Okay, so when we press row 1, because I go down through the columns. So we got 3 columns. Where's my 1K? Pile of 1K resistors. Pile of 1Ks. Hold on just a second. So this whole deal has got a lot more complicated than I expected. So row goes in. So column 1 is the right next to it. Column 1 comes in on pin 6, which is blue. Blue. Column comes on 6, which is blue. So we're going to go from 1 right next to it. Row 1, column 1's right next to it on this keypad. And then I'm going to go from here. And then we have a 1K. It's not hooked up right now, but it's going to go to ground. Alright, there's one of them. So when you press the 1 button, here's your row 1. And then this is your column 1. And then that is going to go through that technically is not going to the column yet. You can see I'm not hooked up on this side. So that column 1, which is right there, is going to go to the collector side of this guy. Then I'm also going to have to connect from, this is all in the same column, go from here. I think I'm out of colors there. I'll pick another one, I guess. Black. I'm not using black for anything. Alright. Do I have another blue? I'm out of blues. I'm out of blue. Oh, yummity. So that's going to go from the high side of here through a resistor, which I haven't decided yet, into there. Alright, so I think I'll try it with 1 column first, and then I need, like, let's see, that goes into the I'm on the wrong side. This needs to be on the collector side. Collector, and then the base needs to go through a 1K to ground. Oh, I'm gonna need a bunch of jumpers. A bunch of jumpers to do this. That's a 1K there. Let's see if I bias this all right. Can you believe I do this for fun? It's crazy. This has turned into a whole lot bigger project than I ever thought it would be. I also got a nice postcard from a gentleman who is the Tiger Learning Computer from Utah. Thank you, Brandon, for the postcard. Never been to Utah. Flown over Utah, never been to Utah. But yeah, that's it for now. I think I need to step back a minute and need to grab my Intellivision II and hook that up and see if this works. So get my scope fired up. Boy, I talk to myself a lot. Okay, so that's what I'm doing next. Well, I think that's it for now, and then hopefully I'll do a little more tonight, but for now I think that should work. Everyone, thank you for watching. Where's my mouse? There's my mouse. Wrong mouse.